Hello again, Tom from Every Step Calculus, everystepphysics.com. This is a line integral. The reason I'm doing this was submitted by a student, him or her, for Yahoo Answers. And the reason I'm doing it now is because of the counterclockwise word in it, which shows you makes you calculate the integral over a certain path direction. And I'm going to show you how my programs work on this. Index 8 to get to the menu, my menu for line integrals. We're going to scroll down here to line integrals. Notice all the subjects that my menu has for solving calculus problems. All step by step, of course. That's the whole trick to it. That's the tough part about it. We're coming to line integrals here. Press enter. And because this problem has dx or dy in it, we're going to choose number 2, dx dy. Okay. Now notice that this is calculus 2 problem probably because there's only dx and dy or x and y. Calculus 3 would be x, y, and z, which I do also, no problem. And the m and the n before the dx and dy tells you what you're supposed to enter here. We're going to enter the m function before the dx term, okay? Now you have to press alpha before you enter anything in these entry lines here, okay? So in other words, this would be alpha x times y. And then we're going to enter the n one. Okay, now you do this here. You'd press alpha and you'd enter x squared times y cubed. Don't leave out the times sign in between it. Now I've entered this already in the simulator to save time. I show you what you've entered. In case you made a mistake, you can change it. I ask you, there's several situations here, but this one has segments. Our line segments given. Segments are these vertices here, called segments in other problems. I say yes, and then I show you the different possibilities there. Some are 2 segments, some are x, y, z, 2 segments, and this one is x, y, 3 of them. Okay, like is indicated here. So you press alpha, enter 0, alpha 0, alpha 1, alpha 0 as I go through the entries here. I've already done this to save time. And so now I show you what we've entered, or what you've entered if you entered these yourself. And I say it's okay, looks good. I'm going to press number 1. Now I ask you whether counterclockwise is mentioned in the problem. If it's not, it's going to be clockwise, which most problems are, but this one's counterclockwise around this triangle. So I say yes, so then the path is going to be 1, 0 to 1, 4, and 1, 4 to 0, 0, okay? Now because there's 2 paths, we need to evaluate the integral over twice, the same integral over twice over the different paths, okay? It's pretty tricky. This will probably never appear on a test, but it will appear in your homework, and this person submitted this to Yahoo Answers for an answer, so I thought I'd do it. I've done about 8 or 10 videos on line integrals. Make sure you check them out. They're all the possibilities, 2 of each, that I come up with tests or homework for line integrals. So make sure you check all those out, and you'll be expert on all this stuff, step by step. We're going to evaluate the first path, 1, 0 to 1, 4. And of course we have to parameterize these paths, okay, which is pretty tricky. Here's the formula for it and the answer. And the second path is this, okay. Now after parameterizing, the range always is 0 to 1, okay? They don't tell you that in your problems. If you try to figure out how they got that. And so then we put in the values for x, and then we find the derivative of it. Values for y, find the derivative of that. And here's the original integral. We substitute the t values. The calculator uses quotation marks, but you're going to put parentheses around these quotation marks so on your paper to look like you know what you're doing, okay? Because we're substituting all the t values for x and y. We simplify. We integrate it over the range of 0 and 1. At t equals 1, turns out to be 64. At t equals 0, turns out to be 0. And upper minus lower, that's in physics or calculus. They always do it that way. And the answer is 64, okay? Now we're going to parameterize the second path, and that's 1.4 to 0, 0. And we do the formula again. Come up with 1 minus t, and of course for the y value is 4 minus 4t. We again do the values for x and y and do the derivatives. Original integral, substitute the t values in there, simplify, we integrate it over the range of 0 and 1. At t equals 1, it equals 0. At t equals 0, it equals 44. Sorry, that was my pathetic phone. Equals 44. Upper minus lower, minus 44. We combine the integrals, and the answer is, and add them together, and the answer is 20. Now notice pathetic line integrals. 20, what does that equal? What does that mean? 20 jock straps, 20 meters, 20 raindrops. Now they'll say that 20 means this electron going through a vector field, and all of a sudden these scientists come up with 20 and they say, oh my gosh, that solves another new formula for solving cancer. You know, that's what calculus does. Bunch of nonsense, solves nothing. Just 1,000 problems that you compute just like Sudoku or just like crossword puzzles, okay? Should only be taught to math majors. But anyways, go to my site, buy my programs, and pass calculus. I don't see why anybody wouldn't spend that type of money to have these in your calculator to be able to do this stuff, okay? So anyways, you have a good one. Talk to you later.